Now we're going to begin to solve. Again, my questions are the same. Can we make this simpler? I don't know. The answer would be no. If you want, then you're going to ask yourself, is it a perfect square trinomial? If you want, is this a perfect square? Is this a perfect square with a plus sign in the front? Is 2 times the square root of A times the square root of C equal to 36? Is 2 times 2 times 9 equal to 36? It is. Therefore, excuse me, I could take the square root of the A term, 2x, square root of the C term, 9, sign in front of B, squared. But again, you don't need to do it that way. We could go from there right to the ACB chart. So if I were to do that, I would need, I'm going to make sure I have this one right, 81 times 4, 324, with a sum of 36. Well, I'm going to have to take a minute. I didn't work this one out in advance. So I'm going to work on the ACB chart a minute, and I know we'll be like, oops, not negative. My sideways 1. 1 and 324. That's too much. 2, 3 goes in there, and so forth. So I'm going to start my list of digits until I come up with a product of 324 with a sum of 36. Pause the video. Let's see if we agree on the factors. Yikes, that took me a lot longer than it should have. I was struggling. But finally, I arrived at 18 times 18 is 324 with a sum of 36. So then I would take my A term, my B that were separated, and my C term. Greatest common factor. So we're going to do grouping. Greatest common factor and identical. So take out my greatest common factor of 2x, leaving me 2x plus 9. Taking out my 9, so I'm left with 2x plus 9. Always time to highlight, kind of a celebration. Combine together your greatest common factor and one of your identicals. We are not all the way done. I did originally ask you to solve this. So 2x plus 9 equals 0. 2x plus 9 equals 0. Subtract 9 from both sides, divide by 2. Subtract 9 from both sides, divide by 2. What does that mean? We were talking about we should have gotten 2 answers. I started with a polynomial to the second degree. I did get 2 answers. In our next section, we're going to be graphing. What this tells me is somewhere on the graph, the parabola rests exactly where x equals negative 9/2. That is the vertex and the roots at the same time. It's going to only touch it one time because both of my solutions were the same number. Okay, to the next problem. Oh, I got fractions for you, but we're not going to freak out. Can we make it simpler? No. I am going to test and see if it's a perfect square trinomial. Again, you may skip that part if you want. Is that a perfect square? Yes. Is this a perfect square? That's a great question. 1/9. To determine if it's a perfect square, you take the square root of the numerator, the square root of the denominator, and I get 1/3. All right. Oh, so that is a perfect square because I could take the square root of each. Is this 2 times the square root of 1 times the square root of 1/9? 2 times 1 times 1/3 does equal 2/3. So square root of the first term, square root of the second term, sign in front of b. Again, you could, because the a is 1, we could have worked with that. I need two numbers that add to negative 2/3 but multiply to positive 1/9. That would again be your negative 1/3, negative 1/3. You could use your ACB chart. All of that would work. Working with fractions adds an extra element. For the next one, can we make it simpler? No. Whenever I have a 1 here, can't make it simpler. Is it a perfect square trinomial? Is that a perfect square? Yes. Is that a perfect square? Yes. Is this 2 times the square root of a, which is 9, times the square root of 1? 2 times 3 times 1? It sure is. That means I would take the square root of the a term, 3x, take the square root of the c term, 1, sign in front of b squared. We could also go right to the ACB chart and it would work. You need to decide what you are most comfortable with. So I need numbers that multiply to 9 but add to negative 6. Well, we know 3 times 3. We would need them to be negative so that our product is positive, but our sum is negative. Then I would have 9x squared minus 3x minus 3x plus 1. That's my A. These two make the B, and that's my C term. Okay, what's next? Grouping. Pull out the greatest common factor. On this one, I almost have exactly what I want, except these are opposite signs, so I need to pull out a -1. Great, I can't lose the opportunity of getting the highlighter out. Now I will group my greatest common factors together, group one set of the identical or highlighted together.